Hello grade 8s, this is Mr. Miller. I'm going to do an intro into chapter 3 and then give you the lesson on section 3.1. So in the introduction here, I'd just like to talk about what we'll be studying in chapter 3. It's all about squares, square roots, and how we can apply these operations to solve problems in right triangles. The key words that are important for this chapter, and you may want to look these words up in your glossary, are prime factorization, perfect square, square root, hypotenuse, and Pythagorean relationship. All of those words are going to be important in this chapter. Let's get on with section 3.1. So this is all about squares and square roots. First of all, when we are talking about the square of a number, we are talking about a number multiplied by itself. Okay? So now we're going to get into some multiplying of numbers by themselves, in other words, finding the square of some numbers, and we're going to evaluate each one of these. So 0 squared, it means 0 times 0, and that's equal to 0. 1 times 1 is equal to 1, and so on. I'm not going to show the step in between, I'm just going to go straight to calculating each one now. 2 squared is equal to 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, and moving back up here, 11 squared is 121, 12 squared is 144. Now I know that's where most of you have learned your times tables up to, but I'm going to extend it a little bit further here, a few more perfect squares that are good to know. 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 20 squared, pretty easy to do, 2 squared is 4, and this one is going to be 400. 25 squared is a good one to know because 5 squared is 25, and then 25 squared is 625. 30 squared is 900. 40 squared is 1600. 50 squared is 2500. So those are a lot of squares that are good to know. Just like your times tables that you've memorized, it's good to memorize these. And as you can see, we've gone beyond 12 squared and added a few extras that will be useful for us. Now let's talk about the square root of a number. So it is the answer that when squared is equal to the number that's under the radical sign. So let's take a look at some examples. The square root of 16 is 4, and I know that this is true because 4 squared is equal to 16. So that's what we're looking for. We're looking for the number that when you multiply it by itself, you get what's underneath the radical sign. And this is the radical sign. Okay? 0.25, the square root of that is 0.5. Again, because if you take 0.5 and multiply it by itself, you get 0.25. The square root of 4/9 is pretty easy to do. You take the square root of 4, you take the square root of 9, and you put 1 over the other. The square root of 4 is 2, the square root of 9 is 3, so the answer is 2 over 3. The square root of 1.44, well, 1.44 looks a lot like 144, and that is a perfect square that we looked at right here. So now, square root of 1.44 is 1.2, which looks a lot like 12, except the decimal's in a different place. Next thing we'd like to do is to evaluate some square roots to 2 decimal places. So if I were going to take the square root of 20, I know that I'm going to get an answer somewhere between 4 and 5. 4 squared is 16, 5 squared is 25, so I'm going to get something in between. And let's see exactly what I'm going to get. I'm going to use my calculator to get this answer. And for me, the square root, I press the second button and then the x squared button, and then I can punch in the 20. I can close the brackets around that or not. I'll still get the same answer. So this rounds off to approximately 4.47. Now the next one, the square root of 123, well, I should be expecting something pretty close to 11 because 11 times 11 is 121. So it should be just a little bit over 11. 12 times 12 would be 144, so it shouldn't be anywhere close to that. Let's find out. The square root of 123 is actually equal to 11.09, so that's what I expected. Again, it's good to think about either estimating or trying to figure out what the answer is before calculating, so that you can get your answer and know that it's a good one. The square root of negative 10. What is the number that when I multiply it by itself I get a negative number? There is no such number. So this one, we are going to say that this is an imaginary number. And so this is not the type of number that we're going to be studying in grade 8 math. If you try to do this on your calculator, the square root of negative 10, you will find that your calculator is unable to do that math. So we will only be taking the square roots of positive numbers, or 0. So that has applications in a few different examples here. For one, if we wanted to find the area of a square whose side lengths are each 10 centimeters, so just draw a quick picture here. Okay. So if we had a square that was 10 centimeters by 10 centimeters, then the area is going to be equal to 10 times 10, and that is 10 squared, which gives us 100 square centimeters. In example 5, we are asking to find the length of each side of a square whose area is 49 square meters. So if I were going to do a scale drawing here, I would draw a square, and I would say the area is equal to 49 meters squared. I would like to know what is the length of this side. Okay, the length from there to there. And so what I will do is I will take the square root of 49, and that is equal to 7 meters. And that makes sense because if we have a length and width that are equal to each other, as is the case in a square, 7 times 7 will give me 49. Now, in this next example, we want to look at some perfect squares. The first one is 36. We want to do its prime factorization. So here's what that looks like. I know that 36 is 2 times 18. And I know that 18 is 2 times 9. And I know that 9 is 3 times 3. So I stop when I have all prime numbers here. Prime numbers are numbers that have exactly 2 different factors, 1 and the number itself. And no, 1 is not a prime number. Okay, so the prime factorization for 36 is equal to 2 times 2 times 3 times 3. I can do the same thing for 4,900. It's going to take me a little bit longer, but I can certainly do it. So it is 2 times, and I may need my calculator to help me out with this process. And also just to speed it up a little bit here. 4,900 divided by 2 will give me 2,450. And 2,450 divided by 2 is equal to 1,225. Now, 2 is not going to go in again because 1,225 is odd. If I think about, will 3 go into it? 1 plus 2 is 3, plus 2 is 5, plus 5 is 10. The digits add up to 10, which is not divisible by 3, so 3 is not going to go in. 4 is not going to go in because, again, this is an odd number, but 5 will go in, and it will go in 245 times. And I know that 5 will go in again, and it's 49 times. And from here I can figure the rest out on my own. 49 is 7 times 7. Now I have all prime factors. So 4,900 is equal to 2 times 2 times 5 times 5 times 7 times 7. So, put the calculator out of the way for now, and let's take a look at drawing some conclusions. How many of each prime factor are there for each perfect square? So for 36, there are 2 2's and 2 3's. In the case of 4,900, we have 2 2's, we have 2 5's, and we have 2 7's. Okay, so what do you notice? Well, I know that your initial look at this, you're thinking to yourself, well, there are 2 of each prime factor. And while that is true, the general case for perfect squares there will be an even number, which just happen to be 2 of each in this case. There will be an even number of each prime factor in the prime factorization. So that is a property of perfect squares. And that concludes this lesson. Homework is listed at the bottom. And thank you for watching this video.